Gets ready to solve numerical on electric field. I have a question for you. In this question, I am taking two parallel plates having electric field 2 10 to the power 4 Newton per coulomb. Let us keep a charge. Let us keep a charge of mass 9 10 to the power minus 31 kg and 1.6 10 to the power minus 19 coulomb. So it is an electron. So we have kept an electron between these two plate. What we find? We find that the electron moves from point A to point B and it covers 6 centimeter distance. Then the question is, what is the time taken to cover distance of 6 centimeter? Let us solve the question. For solving this question, we have the formula electric field E equals to force per unit charge. So you have electric field E is equal to force is equals to ma here and charge is E here because there is one charge. So you have A is equals to small e capital E upon M. You know the formula, S is equals to ut plus half at square. So U is equals to 0. Therefore, S is equals to 0 into T plus half. At the place of A, write this. At the place of A, write this E capital E upon M into T square. So you have T equals to 2ms upon small e capital E root. So this is the equation. Now put the value. So you have the value, this is equals to 2 and the value of M, mass is given 9 10 to the power minus 31. The value of S is 6 10 to the power minus 2 in meter and E is 1.6 10 to the power minus 19 and capital E is 2 10 to the power 2 into 10 to the power 4 under root. So arrange this first. So when you arrange it, you have first you cancel this 2, it will cancel out and you have 9 upon 16 into 6 into here you have when you eliminate this point you have 10 to the power minus 20 10 to the power minus 20 plus 4 is 10 to the power minus 16. When you move to upside you have 10 to the power plus 16 and you have 10 to the power minus 31 and 10 to the power minus 2 is 10 to the power minus 33 already here. So you have 9 upon 16 into 6 into 10 to the power minus 17. This can be written as 3 upon 4 under root. You can write 6 upon 10 into 10 to the power minus 16. From this 17 we have written minus 110 to the denominator side. So we cancel this with 2, we have 3 here, we cancel and this with 2, we have 5 here. So you have 3 upon 4 into root 3 upon 5 into 10 to the power minus 8 when you take out up from the root. So you have 3 upon 4 is 0.75 and root 3 is 1.732 and root 5 is 2.236 and here 10 to the power minus 8. Now next when you write the values, so you have time t is equals to 0.75 and this is written as 0.77 and here 10 to the power minus 8. When you multiply it you get 0.58 10 to the power minus 8 second. Thus the time taken to move this charge particle from A to B is 0.58 10 to the power minus 8 second. Let's learn the second numerical. The second numerical is, here you have an oil drop. An oil drop have mass 2 10 to the power minus 16 kg and the charge on the oil drop is 10. There is 10 charge on the oil drop is, and this oil drop is kept between two plates having 5 mm separation. Then what is the potential applied? So the oil drop will be on air, it will not fall down. Let us find the potential V. For this you know the formula E equals to F upon Q. Here E is equals to V upon L and here F is equals to M into G and charge E equals to NE. So you have V is equals to mgl upon Ne. Put the value. The value of mass is 2 into 10 to the power minus 16. value of G is 10 and value of L is 5 mm. So it is 5 10 to the power minus 3. Value of N is 10 and value of E is 1.6 10 to the power minus 19. Let us solve this. So when you solve it, you get on the numerator side 2 into 5 10 and here already 10, so 10 to the power 2 here, and minus 16 minus 3 10 to the power minus 19 here, and on the denominator side 1.6 into 10 is 16 and here 10 to the power minus 19. This will cancel out, so you have 0.0625 into 10 to the power 2, so this is equals to 6.25 volt. So the voltage required to hold this charge particle of having charge 10 in air is 6.25 volt. Do like, subscribe and share my channel. Thank you.